For decades, acquiring information online meant scanning a list of blue links, clicking a headline, and reading a web page. Today, the search engine simply generates a definitive answer right on the results page. This behavior is known as the zero-click search. The user submits a prompt, receives an immediate AI-generated summary, and closes the tab without ever visiting the source website. Securing the top spot provides no guarantee of website traffic if the user finds their answer directly on the search page. Success in 2026 relies on providing raw data for an AI to scrape, rather than convincing a human to click a headline. Achieving visibility requires treating content as the foundational source code for an AI's generated response. Surviving this environment requires a shift toward a three-tiered optimization model. Traditional SEO, or search engine optimization, continues to function as the baseline requirement for getting a page indexed by crawlers. In this three-pillar architecture model, the middle tier introduces answer engine optimization, or AEO. AEO focuses on technical structuring, allowing AI systems to extract information as a direct citation. The final layer is generative engine optimization, or GEO. While AEO manages the technical structure, GEO operates at the content layer. It ensures that large language models comprehend the actual ideas and entities within the text, allowing the AI to integrate those concepts into a synthesized response. To succeed across these three tiers, creators must prioritize engineering highly deterministic data structures that machines can parse. To understand why these structures are necessary, we need to look at the internal mechanics of an AI answer engine, the exact millisecond a user submits a complex prompt. Large language models operate entirely differently than traditional search crawlers, functioning through an internal mechanism called the fan-out query. An AI generates multiple internal subqueries simultaneously to gather various fragments of information and compile a comprehensive answer. These subqueries hunt for specific, rigidly formatted data nodes, and they bypass unstructured paragraphs of text. Because of this behavior, optimizing a page for a broad, singular keyword is obsolete. Content must be designed to intercept these fractured, hyper-targeted subqueries at the moment they are generated. Web pages that lack modular micro-answers are consistently bypassed by the fan-out query. Intercepting a fan-out query requires specific, rigid page layouts. Winning these queries requires the deployment of answer-first content. This documentation details the core requirements for AI optimization. The first row defines answer-first content, dictating that the answer must be delivered immediately at the top of the page. The traditional funnel of an introduction leading into a body paragraph is defunct. You must use an inverted pyramid structure, giving the machine the exact data point first and providing context later. This hierarchy illustrates AI preferred formats. AI parses structured data more reliably than prose. Ranked lists sit at the top. Their sequential numbers establish explicit mathematical relationships. Conversely, unranked bullets and articles offer weak parse signals, making the AI lose confidence in your data's relationships. Structural formatting serves as the API that allows an AI to ingest your content. This requirement for structure extends past the overall page layout, down to the microarchitecture of individual sentences and paragraphs. To guarantee a citation, you have to write highly engineered sentences, known as citation hooks. Citation hooks are tight definitions or isolated statistics requiring precise spacing. You must embed them every 150 to 200 words. This gap aligns with the AI's extraction window, perfectly matching the length of data chunks large language models process for zero-click summaries. To ensure the AI actually finds these hooks, you apply schema markup, specifically FAQ schema. This backend code acts as a map, guiding the AI parser directly to the sentences you want extracted. Flowing, uninterrupted prose creates a liability for indexation. Content must be built as a rhythmic series of machine-readable data nodes. However, even perfectly engineered citation hooks will be ignored if the AI system lacks baseline trust in the website hosting them. This brings us to Google's concept of entity-level EEAT, which stands for experience, expertise, authoritativeness, and trustworthiness. Trust isn't calculated from a single page in isolation. It's permanently attached to the overarching entity, the brand or author generating the content. Building this trust requires intent clustering, systematically grouping content by whether the user's intent is informational, commercial, or transactional. Flawlessly executing intent clustering across an entire domain proves comprehensive expertise, resulting in absolute topical authority. This systematic, exhaustive coverage of a specific topic positions the entity as a primary reference node for the parser. AEO and GEO focus on engineering the trusted data environments that AI systems are structurally designed to cite.